Okay, everybody, this next video will be much shorter. We're talking about forces. And in this chapter, we will focus on the forces that we can see and interact with. So pushing and pulling forces. So we have two guys trying to move a big sofa, chair, whatever, lazy boy chair? I don't know what that is. But this guy is pushing and this guy is pulling. They are working together to move the object. So a force is a push or a pull described by 1, its strength, and 2, the direction of it. So he might be pushing with a force of, we use newtons to describe force, so he might be pushing with a force of 10 newtons, and he might be pushing with a force of, pulling with a force of 12 newtons. And those forces would add together. What's 10 plus 12? That's 22. Overall, the force would be 22 newtons to the right. Okay? And so just like coming back to this, force is measured in newtons. This is just like we use seconds to measure time, we use grams to measure mass, we use meters to measure length. So when it comes to forces, it's newtons, okay? Next we're going to talk about net forces. A net force is the combination, the sum total of all forces acting on an object, and I kind of gave you an example up here already. But if two forces are working in the same direction, they add together. That should be common sense to you. And if two forces are working against each other, they counter each other or they subtract. Okay? So balanced versus unbalanced forces. So all of these examples over here on the right, the little arrows, these are unbalanced forces acting on an object. This results in a net force, which causes a change in an object's motion. So if the net force is anything other than 0, it will result in a change. And so I always imagine you have like a person here, and he is pushing, and then this other person is also pushing, but this guy's pushing with 10 newtons, this guy's pushing with 5 newtons, so the overall net force would be 5 newtons to the left, because 10 minus 5 is 5. Okay. Next, let's say it's kind of the opposite. This guy he's pulling that way. Gosh, I'm such a terrible artist. And this guy is pulling that way to the right. So again, 10 minus 5 is 5 newtons to the right. If these two people actually happen to be working together, and what are these people? They're all legs. They're pulling or pushing both to the right, then we just add them together. 5 plus 10 is equal to 15 newtons of net force to the right. And then the other side of that is if the forces actually happen to be equal and opposite, then those are called balanced forces, and they do not cause a change in motion. You sitting in your, oops, I bumped into the smartboard. You sitting in your desk is an example of this. So let's say there is 50 newtons of force pulling down on you. Okay, we're factoring gravity into that. But then if you're not moving, that means there must be 50 newtons of force pushing back up on you. The result is nothing exciting other than you go nowhere. Okay? How do I get out of this? Okay, I wanted to show you this website. It's called fet.colorado.edu, and if you go to simulations and physics, you can find this. I've already downloaded this one, but again, fet.colorado.edu, go to simulations, physics, and then you should be able to find this one. It's called Forces in Motion, and you are welcome and encouraged to play with these and see what you figure out. If you go to net force, you can have a little bit of you can run a tug of war. So they're each going to apply 50 newtons of force. Okay, the sum of forces is 0. So if we hit go, you can expect it not to go anywhere. But if I add this guy's big brother, all of a sudden we get some unbalanced forces and we get motion. Okay, you can pause, return. So feel free to play around with that. This is an awesome website. There are also you can put this little guy up here, increase your newtons, Okay, it might take a while. You can see he's barely starting to move. We can add our forces here. Mass. So the box is 50 kilograms, he's 80 kilograms. It's taking a lot of force to get that moving. Okay, but the more force you add, actually, the more he will speed up. Okay, so again, feel free to play around with these. They're just a lot of fun. This one adds friction, which is actually our next topic. And this one talks about acceleration. So please have fun with this. We will be completing an assignment with net forces soon here in class. Thank you and good luck. How do I get out of this?